Okay, the 4 pillars of the Bitcoin system. Actually, it's about compatibility, composability, parallelism, and scalability. This is somewhat a bit abstracted, but I will guarantee that I can use real-world instances to demonstrate what it is and how we are going to pursue it. Before this, I will explain that why we are talking about Bitcoin, not Ordinals. Because we are always, as a team, we are always treating the Ordinals from an external view, from the whole Bitcoin ecosystem. We want Ordinals to help the Bitcoin to grow, not only for the Ordinals itself, for the Bitcoin to grow. Okay, let's start with the congestion problem we met in May. In May, we delivered the marketplace, but months before the Ordinals is released on January. And after that, the Bitcoin mempool is actually congested for a while. And there are many transactions there to be processed for the main network. And we want to we take it really seriously. We want to solve it, or at least mitigate. Or next time the Bitcoin network gets congested again, people will lose confidence to the whole thing, and there will be more arguments on it. So as an active member, UNISAT have to find a way to solve it. The first natural sort about this is trying to make Ordinals transactable on Lightning Network. But in our deeply research, we found 2 fundamental compatibility issues. They are fundamentally incompatible in 2 ways. The first one is a specific Satoshi with its data is non-fungible, and the property prevents easy transfer across a Lightning Network channel. This is fundamentally incompatible with LN, and it cannot be easily solved. And the second one is the Ordinals becomes recognized after they are included in blocks. But the LN transactions occurs only in mempool. So these are really serious issues we want to solve. And we have a naive approach for this by actually modifying the LN source code, by modifying it into something that being compatible with Ordinals. But the trade-off is it doesn't being compatible with Bitcoin again. So we have 2 networks. One is for Ordinals, the other one is for Bitcoin. So we have to find a higher level communication protocol for it. Just something like IBC on Cosmos. Then we make things complicated and more complicated. You know, the LN is complicated enough, so it's not a good idea. After that, we make more research about how to utilize the BRC20, use the power of BRC20 to solve the problem inside the boundary. Then we made an experiment to create a Lightning module. It's a BRC20 module for Lightning Network only. In this way, we can utilize the existing protocols like Taproot assets. All we need to do is transfer Ordi, assets like Ordi into that module as compatible assets. In this way, we remain 2 important attributes of the BRC20 system. The first one is simple, keep it simple, just like Domo said. Keep it simple, and we can reuse existing constructs like Taproot assets without introducing too many high-level concepts to making people believe that it's a workaround solution. We just have to utilize existing matured constructs. So what is a module? This is the idea proposed by Domo months ago. He explained it a bit, but to be honest, I didn't get it by the first time I heard it. It's about how to extend BRC20 in a sustainable way. Why are we mentioning a sustainable way? Because if we extend BRC20 in an unmanaged way, it will quickly get out of control. Everyone wants to add new features to it, and you don't have an undo button for it. So we have to do it carefully without breaking things. The main power of the BRC20 is from its simplicity. We don't want to break it. So to keep the core protocol plain and simple, we have to achieve these goals, prevent it from being incrementally messed up. Extensions should behave in isolated modules. And there should be a reasonable way to transfer assets in and out of the modules. And on top of this, we should find a better way, a good way to have a strong and committed consensus around which module is valid, which module is accepted, which module has a relatively poor implementation, and which modules should be merged into a higher level. But it shouldn't hurt the attribute to develop it. It should be permissionless for anyone who wants to develop a solution based on BRC20. After I heard the initial idea of the modular design, I actually proposed a legacy approach for it. It's some idea from OpenGL. If you know the history of OpenGL, I'm a game developer and I'm quite familiar with it. The OpenGL model is a lot of vendors like NVIDIA, AMD, and Intel. They are develop extensions for OpenGL in their own way, with their own extensions only supported by their own drivers. It's actually a permissionless way to deal with the extensions, but it's not a good model. It's not a good example for this, because after several years of development, OpenGL is very slow to evolve. So it actually ceased to functioning. So the ARB has the whole new version for OpenGL. It's called Vulkan. So it's not a good idea. It's not a good model. We have to find a smarter one. After that, we have many prototypes on this, and then we found this one. It's called Scoped module. It's like a namespace. If you're a programmer, you are very familiar with what namespace is and how it behaves. It could be embedded namespace in namespace. And the main attribute of it is they are mutually exclusive. It means you have to withdraw assets from one module first, then transfer it into another one. So you cannot have your assets in both modules simultaneously. And the modules are physically isolated without affecting the core functionalities of BRC20. Black module mode. In this mode, you cannot withdraw from it. You can deposit your asset into it, and everybody can deposit and try out the features the swap provides, but it doesn't allow you to withdraw from it. After the swap implementation is widely verified, the source code of it is widely reviewed. We may be able to turn into phase 2, which we will enable the withdrawing from it. By turning into phase 2, it means all indexers agree that the rules are at least harmless to the protocol. But still, we can make a module to stay in phase 1, even forever. In this way, you can still withdraw it if anyone wants to deposit it, so you can make an exchange with others. So even in phase 1, you can withdraw with you can exchange with others to withdraw your assets. So there will be a lot of modules stay in phase 1, and some of them get accepted into a white module, which is 100% transparently accepted by all indexers. By looking for the solution, we gradually realized that the nature of BRC20 is quite surprised, because when Domo asked me about the BRC20, I frankly answered him that even in May, I didn't find the merits. I didn't find the inner merits of BRC20. 2 months after that, in July, I suddenly realized that BRC20, the beauty of BRC20 is it's floating above Bitcoin. It's not something that is tightly bound to the Bitcoin itself, just like a Lightning Network. The Lightning Network relies heavily on the Bitcoin transaction structure, but BRC20 is not. It's floating above. It's not designed to be tightly bound to the underlying physical structure of Bitcoin. This is a huge benefit to us. It makes it a perfect glue layer for different protocols, like Lightning Network, EVM, or some other domains. And that's what we want to do using the module system. To achieve a global level compatibility, we did such experiments and prototypings. The first one is the swap. It is Bitcoin native, running fully inside Bitcoin system with the core protocol. But the 3 other real-world cases, I mentioned it in 3 different ways. The first one is protocol specific. The second one is chain specific. The third one is domain specific, which shows the great power of BRC20 implementation we can make in different levels of abstractions. If we can make a module that supports Lightning Network, we can have BRC20 smoothly transacted on Lightning Network using its native implementation like Taproot assets. We have a partner which is very strong, has an implementation about how BRC20 interact with EVM. We call it BRC0. And UNISAT has the implementation for open game framework, which is friendly for game developers to utilize Ordinals for their own purpose. This is the external viewpoint, the external perspective we have. We always want to see these things from an external view, see how the real world can leverage BRC20 Ordinals to achieve their own goals. We're not trying to build the community. We're trying to use it to help real-world cases. Okay, I will take a closer look for each of them. The first one is the swap. We have many iterations based on the initial one, and this is a recent version we are having in our in-house test. There are actually some main features I want to mention. The first one is it's running in an inscription-based virtual machine. Why I'm calling it virtual machines, not a callable, executable code, is because it's actually well maintained inside the whole Ordinals. It can behave, it is Turing complete, it can execute everything you want, but in a restricted manner. It's actually a recursive framework utilizing the recursive inscriptions to have their core dependencies. And the second thing I want to mention is we have a rollup optimization for it. We did carefully design it to enable that the rollup is generic operations is for many more advanced operations like swap and other Ethereum cases, existing cases on Ethereum. So it helps the whole system to scale on the fly. We can decide how and when and how much we want to roll up things. It's permissionless to clone, deploy, and the permissionless comes at two levels. The first level is permissionless to deploy the whole thing for everyone to deploy it. The second layer of permissionless is you can freely create any trading pair by anyone from any time, even if there are existing trading pairs for two assets. You can create as many as you want by giving different incentive models. The second use case is the BRC0, which is the EVM-oriented BRC20 module. This is from our partners. They create a BRC20 module for interacting with EVM. To use it this way, the BRC0 provides the contract it's executing, it's a solidity contract executing, and the general upgrading mechanism on EVM. And they also maintain the data consistency by the Ethereum blocks. It also supports matured DeFi on EVM. So actually, this is a convenient way for people to introduce BRC20 to different chains. I don't know if it's right to do things in this way, but if people feel it's good, then more people will using their services and creating more transactions, and that would become more popular, and we can provide better support for it, which is a healthy cycle. The last case I want to mention is an open game framework. This is actually created firstly by UNISAT itself. We discovered an merit from the Ordinals. It's actually something from the recursive inscriptions that we can not only create composable art, but also create composable code. We can reuse components by inscribe them into inscriptions. And we can build complicated libraries and frameworks and even runtimes for programmers to run their advanced programs. And we can embed virtual machines in the inscriptions. Actually, the Lua interpreter is quite small and could be inscribed into one inscription. This reveals a really important merit of the system. The system is fundamentally composable for artists and for programmers. They have freedom to develop more things on it. Using this, actually, we can build a virtual world in Ordinals. The 4 use cases I described are the existing cases in the short term, but with a long-term goal in mind. We are seeing the Bitcoin as a system with these 4 pillars. Since I don't have pretty much time, so I will explain it briefly. For the compatibility, the more things we're compatible with, the more neutral we are to stay in a neutral mode for larger adoption. We don't inherently encourage or disagree with something. We just support all of them and let users decide. We will try to build more compatibility with more protocols without bias. And for the composability, like I showed in the open game framework, we just want to lower the barrier. We don't want them to learn details about Bitcoin development. Actually, many programmers choose to use Solidity just because they don't want to understand the enormous details in Bitcoin. With these 2 short-term goals, we can discover more intrinsic attributes of Bitcoin, which is parallelism and the scalability. I hope the system could become a system which is native so that we can utilize the parallelism and which is simple by using more composable art, composable code to form a pipeline for more developers, and which is versatile because it supports more protocols by fixing the compatibility. And the system could be strong because it scales. Please note, I'm not mentioning that the blockchain, the Bitcoin blockchain is scalable. I said the system should be scalable. The Bitcoin, the blockchain, should act as its backbone. Okay, here is the takeaway of the whole thing. I just explained the what and how. The 4 pillars, which are our goals in coming months and years. We want to build Bitcoin into a system. And how we did it, how we are going to deal with it. We are extending BRC20 using modules and more modules. Some of them will be developed by UNISAT and some will be delivered by others, which will make it be native and protocol friendly, chain friendly, domain friendly, and make the BRC20 the best connection for all across all protocols chains. Okay, I really hope everyone in this room stay native, stay simple, be versatile, and be strong. Thank you.